Lecture number 11, the dimensional analysis. The learning objective of this lecture this lecture is cover lecture this objective cover lecture 11 and lecture 12. Okay. For the first learning objective is apply the Buckingham Pi theorem. Okay. The second, develop a set of the dimensionless variable for given flow situation. The third, discuss the use of dimensionless variable in data analysis. And the fourth one, apply the concept of modeling and similitudes to develop the prediction equation. Very few engineering problems involving real fluid can be solved by using equation and the analysis procedure alone. Okay, the solution is required the use of the combination of the theoretical analysis, numerical analysis, and experimental data together. The next topic is we call the theoretical analysis using the dimension analysis. Okay, a typical problem with the experimentation is required steady flow of the incompressible Newtonian fluid through a long, smooth wall horizontal circular pipe. Okay, for the design of a pipeline. So that important characteristic in this case, we want to know what is the pressure drop per unit length. That is the pressure drop as a result of the friction. Okay, so that is the pressure drop. The delta PE is equal to the different pressure between P2 and P1, P2, and divided by the length. Okay, that is the definition of the delta PE. The first step in the planning of the experiment, decide which factor or variable have been an effects on the pressure drop per unit length. So we can find that the pressure drop is function of diameter. This is diameter, the density of the fluid, the viscosity of the fluid, and velocity of the fluid. Okay, and this is the diameter, rho density, mu is dynamic viscosity, and v is velocity. Okay, if we set up the experiment from the theory of the test, and this figure show the relationship between, if we just fix the diameter, density, and viscosity, we can vary the pressure with the velocity to get the curve like this. It means the velocity increase with the change of pressure, and if we fix the velocity rho and mu, the pressure is decrease with the diameter, and pressure increase with the density, and different pressure increase with the dynamic viscosity. Okay, but the problem is how can we combine this data to obtain the just general functional relationships between these five parameters valid for any similar pi system. Okay, so as a much simpler approach, we can combine 5 variables into just 2 dimensionless product or groups. Okay, just 2 groups of the variable represented by the single universal curve in this figure. So if we can combine together just only the 2 parameters, and we can run experiment to get the single curve. Okay, that this condition would be much simpler, easier to do, and less expensive. Okay, so we can write that the first product is a function of the second product. Okay, the second groups, and physical quantity can be given in terms of the basic dimension, mass, length, and time, or in terms of the force, length, and time. Okay, and this show the basic dimension for force equal to mLT power minus 2. But in this case, if you don't remember this basic unit, we can start from our memory about the force equal to ma. Okay, and the unit of force is the mass is kilogram, and acceleration is the mass per sec square. Okay, in this case we can convert from kilogram to mass. Okay, and from meter to the length, and second is the time, minus power minus 2. So we can find the basic unit from the unit of this parameter. Okay. And don't forget that for delta P is a different pressure and divided by length. Okay. And we can prove that the two set of parameter is that if we substitute the basic unit in this term and this term, so we can prove that the combine to get the for m is equal on the top we got m and length power minus 1 and t minus 2 and divided the same m length minus 1 and okay, so it's been we got to 1. So that is the we call the dimension as a variable. And for the second group is the same. We can prove that the top is unit of the L, m L power minus 1 and t minus 1 divided the same. Okay, we can prove that the unit is cancelled on both top and bottom. Okay.